examine major 19th century bridges, the official explanation appears simple. Industrial expansion, rail development, and rapid urban growth demanded stronger crossings. Engineers responded with iron spans and masonry supports. That is the version presented in textbooks. But the deeper you look, the more unstable that explanation becomes. Because the visible part of a bridge, the arches, the iron trusses, the roadway, is not the most difficult part to construct. The true complexity lies below the waterline. Foundations require excavation into unstable riverbeds, diversion of flowing water, deep stone placement, structural stabilization, and continuous maintenance during construction. In the 1800s, this was one of the most dangerous and expensive engineering operations possible. That level of work leaves records. It leaves contracts, diagrams, excavation logs, technical reports, budget expansions, delays, disputes, and redesigns. And yet, in archive after archive, something unusual appears. The upper structures of many major bridges are documented in detail. Iron deliveries, labor wages, completion ceremonies. But when the paperwork reaches the foundations, the language changes. Existing base reinforced, earlier masonry retained, substructure reused, prior abutments incorporated, no origin, no construction date, no technical explanation of the original build. Across multiple countries, across different empires, across decades, the same phrasing repeats. Existing. That word raises a problem. Existing from when? When you compare bridge foundations from London, Eastern Europe, Russia, and Central Asia, where structural similarities begin to emerge. The geometry of the cutwaters, the proportion of the piers, the stone shaping techniques, the way the foundations taper into river currents. In some cases, the masonry appears far older in style than the superstructure above it. Iron spans from the late 1800s sit on stone bases that do not match the same construction language. In renovation records from the early 20th century, the pattern becomes even clearer. Superstructures were replaced, decks widened, railings modernized. But the foundations were preserved with unusual consistency. Demolition often stopped at the waterline. Why? Because removing a foundation is expensive, yes, but so is rebuilding one entirely. And yet the choice was repeatedly made to preserve what was already there instead of constructing new substructures from scratch. In some inspection reports, engineers noted extreme stability in riverbeds composed of soft sediment, areas where modern construction would require deep pilings or reinforcement. Yet the older stone piers remained intact with minimal settlement over decades of flooding and ice pressure. There are even early photographs showing completed bridge bases before official construction dates assigned later in municipal histories. This does not automatically prove an ancient origin, but it creates a contradiction. Either 19th century engineers developed and executed highly advanced substructure techniques across vast regions with limited documentation, and then left almost no technical trace of that process, or they inherited foundations that predated the official timeline and simply adapted them for modern use. That possibility shifts the entire narrative. Because bridges do not exist in isolation, they connect trade routes, they anchor cities, they follow corridors of movement that often predate the political borders we recognize today. When you map the oldest surviving foundations, a network begins to appear, one that aligns with older cartographic references, including regions once labeled Tartaria on early European maps. This does not mean every bridge is ancient. It does not mean every foundation is mysterious. But it does mean the timeline is less stable than it appears. If the hardest part of these structures already existed, then the 19th century may have been less about construction and more about adaptation. And if that is true, then modern civilization may be standing, quite literally, on inherited infrastructure. In the next episode, we're going to examine something even more difficult to ignore. Not the stone above water, but what has been sealed, filled, and removed beneath it. Because in multiple cases, access to lower structural levels was deliberately closed. And that decision was not engineering, it was administrative. Once the foundation inconsistencies become visible, The next logical step is simple: access. If these bridge substructures were built in the 19th century, engineers would have documented every internal space: inspection corridors, drainage channels, reinforcement chambers, all of it. Infrastructure of that scale requires maintenance access, and maintenance requires plans. So I began looking for original cross-sections and early blueprints. And that is where the pattern changes again. In several late 19th century plans, internal stairways are clearly drawn inside the bridge piers. Narrow descending passages, arched internal rooms, subsurface corridors connecting foundation blocks. Some even show multi-level chambers beneath the roadway. These are not decorative features, they are engineered voids. Yet when you compare those early plans to later revisions from the early 1900s, those internal spaces vanish. The drawings simplify, access points disappear. Walls are shown as solid, where earlier versions indicated cavities. Renovation logs from the early 20th century use consistent language. Lower access sealed, substructure entry closed, internal chamber filled, non-essential voids eliminated. No technical justification accompanies these entries. Closing access makes inspection harder, not easier. It increases long-term risk. It complicates structural monitoring. There is no engineering advantage in permanently sealing inspection chambers, especially in masonry foundations exposed to constant water pressure. So why do it? In some cities, early photographs show visible doorways or stone arches at water level that no longer exist. In modern images, those same areas are solid stone or reinforced concrete. In a handful of rare interior photographs taken during repairs, the masonry inside these piers appears older than the upper structure. The stone shaping differs. The curvature of the arches follows proportions inconsistent with late industrial standardization. In some cases, blocked archways are still faintly visible beneath plaster or in fill. This suggests that something was not removed, it was concealed. There are also records of workers encountering voids of unknown purpose during maintenance. These discoveries were not investigated in detail. The standard response recorded in multiple archives was simple: fill and seal, no archaeological survey, no structural analysis beyond surface inspection, no public reporting, just closure. By the 1930s, most of these lower levels had become inaccessible. By the 1950s, many were forgotten entirely. That timing matters, because this period overlaps with broader historical shifts, modernization campaigns, infrastructure standardization, and the consolidation of national engineering authorities. Old, irregular systems were replaced with predictable, documented frameworks. Anything inherited but undocumented became a liability, not destroyed, stabilized and buried. And when access is removed, interpretation becomes controlled. Once sealed, those chambers no longer invite questions. The public sees only what stands above the river. Engineers work only on visible components. Historians reference only the assigned construction dates, and the deeper layer disappears from practical memory. This does not prove a lost empire. It does not confirm Tartaria built every structure, but it does establish something measurable. There were structural elements beneath many major bridges that predate their official documentation. Those elements were accessible at one time, and then access was systematically removed. When infrastructure is sealed rather than studied, it suggests one of two things. Either it was too dangerous to maintain, or it was too inconvenient to explain. In the next episode, we're going to move beyond architecture, because sealed stone is only part of the pattern. The more unsettling shift happens in the records themselves. Construction dates begin changing. Language becomes standardized. Older descriptions disappear. New narratives solidify. And once that happens, the inheritance becomes invisible. If the foundations were inherited, and if access to their lower levels was sealed, the next question becomes unavoidable. When were these bridges actually built? Because the official dates are surprisingly clean, too clean. Most major 19th century bridges today have precise construction years attached to them: 1874, 1882, 1891. Clear plaques, clear records, clear narratives. But when you go back to earlier documents, maps, engineering journals, municipal surveys, something strange appears. In multiple cases, bridges are shown on maps before their supposed construction dates, not under construction, not proposed, already standing. Early atlases from the 1820s and 1830s depict river crossings at locations where official records claim the bridge was built decades later. Sometimes the label simply reads "Stone Crossing" or "Existing Works." No fanfare, no announcement, just presence. Then later, editions of the same maps assign a date. Suddenly that existing crossing becomes constructed 1883. The structure didn't appear, the date did. Engineering journals show similar inconsistencies. Mid-19th century publications describe repairs and reinforcements on certain bridges, strengthening the deck, widening the roadway, replacing railings. But the same bridges are later described in early 20th century documents as newly constructed in the late 1800s. How can a structure be repaired decades before it is built? The answer given is usually replacement. We are told there was an earlier wooden bridge, then it was replaced with stone, then replaced again with iron. But the photographic record does not support that sequence in many cases. Early photographs show fully developed masonry foundations already in place, not temporary structures. No scaffolding, no transition phase, no clear demolition of a previous design. Just complete bridges appearing in the visual record as if they had always been there. Another detail complicates the narrative further. In several municipal archives, the earliest surviving documents for certain bridges begin with upgrades, not origin. The first paperwork available is about maintenance, reinforcement, expansion, never initial construction. When major infrastructure projects occur, they generate enormous documentation. Surveys, soil tests, financial debates, engineering proposals. But for some of these crossings, those foundational files do not exist, and they begin in the middle of the story. Then there is the language shift. In earlier documents, phrases like ancient works, former river structure, old masonry base appear occasionally. By the early 1900s, that language disappears. It is replaced with Victorian foundation, industrial era engineering, modern civic project. The uncertainty vanishes. And once a specific year is printed on a plaque, it spreads. Textbooks adopt it, tour guides repeat it, academic papers cite it. Within 2 generations, it becomes unquestioned fact, not because it was proven, because it was standardized. This does not require a coordinated conspiracy, it requires administrative pressure. Governments in the late 19th and early 20th centuries were consolidating identity. National histories were being formalized. Infrastructure became proof of progress. Messy origins create instability. Clear timelines create authority. So ambiguity is removed. Unknown origins become assigned dates. Inherited structures become achievements. Repairs become construction. And once that happens, questioning the foundation becomes socially unnecessary. The bridge belongs to the modern state. Its builders are credited to the modern era. Its deeper history becomes irrelevant. But when you align maps, early repair logs, and photographic evidence side by side, a pattern emerges. Some of these bridges existed before their official construction dates. Some were modified rather than created. Some were adopted rather than designed. Which leads to a larger question. If these crossings were already there, even partially, who built them? And why did the administrative narrative shift so aggressively around the turn of the 20th century?